question 4, the integral is the integral of arctan of 1 over x dx. Okay, so this indefinite integral, when I look at this, I see this arctangent in here, and we know nothing about the antiderivative of arctangent. So really the only tool that we have is to work with integration by parts. And that makes sense for a few reasons. One is because the I in our acronym is second in line after log, so inverse trig. Okay. So that makes sense. And another reason that this makes sense is because we do not know a nice antiderivative for arctangent, then a good choice for you is going to be that arctangent function, because then we'll take a derivative of arctangent as opposed to an antiderivative. Now, one thing you want to be careful of here that I saw a couple of times is this arctangent function cannot be separated from the 1 over x. This is not multiplication in here, and so this whole thing, integration by parts is u times dv, so we can't separate that into a product of two things. So I have to have my u be the entire arctangent of 1 over x. And that leaves for my dv just dx. So my antiderivative of dx is easy, that's just an x. And when I'm looking at my derivative of arctangent, because it's arctangent of something a little bit fancier in here, I need to think about, okay, I need to use the chain rule. So the chain rule says take the derivative of the outside, keeping the inside the same. And so derivative of arctangent is 1 over 1 plus x squared. Keeping the inside the same means that that inside, instead of the x squared, I have 1 over x quantity squared. Derivative of the outside, keeping the inside the same, times the derivative of the inside. Now, the derivative of 1 over x, well, I might rethink this as the derivative of x to the negative 1, and so now I can use my power rule. So I bring that first power down, negative 1, and then I have x raised to the negative 2. So my derivative of the inside is negative 1 over x squared. Okay. So my full du is 1 over 1 plus 1 over x squared times negative 1 over x squared, and then I have a dx here at the end. Are there any questions about my derivative of arctangent of 1 over x? Okay, so I go back over here to my integral, and I'm looking at the integral, let me say that again, the integral of u dv is equal to uv minus the integral of v du. And so in our case, our u is arctangent, so we have arctangent of 1 over x times the v, which is x, minus the integral of v, which is an x, times du, which is kind of ugly here, 1 over 1 plus 1 over x squared times negative 1 over x squared dx. So there's an awful lot going on with this integral here. And what I want to highlight here at this point is that when I have all of these things in here, okay, I'm going to want to simplify. So there are several different ways I can go about simplifying. And one thing that I saw a couple of people do, which I thought was really nice, and I want to highlight this here, is some people actually simplified up ahead of time. Okay? And if you do that, I can also think of doing that down here as well. So I'm going to ignore the x in the front and simplify the rest of what I have here, which means distributing this x squared across my denominator. And so we have arctangent of 1 over x times x minus the integral. In my numerator, I have a negative x. And in my denominator, I'm distributing this x squared to each of my terms. And so I end up with x squared plus 1.
Can't you just throw your negative in front of the integral too?
Yeah, absolutely. And that negative sign up on the top there, and I also have a dx in the end. So I've cleaned this up a little bit, and that negative sign, I can even bring that out in the front. And so I end up with arctangent of 1 over x times x plus the integral of x over x squared plus 1 dx. And so this looks an awful lot better than it did earlier on. And so now at this point, this integral is a u substitution. If I let my u be equal to x squared plus 1, then my du over dx is 2x. And so dx is equal to du over 2x. And so we've got arctangent of 1 over x times x plus the integral, well, let's see, our x's are going to cancel. I'm going to have a 1/2 out in front, and we're left with a 1 over u du. Any questions about that step? I just did all the canceling without writing all the steps out. Okay, now this antiderivative is one that we know. This is our natural log, so we've got arctangent of 1 over x times x plus 1/2 times the natural log of the absolute value of u plus c, and I'm nearly done as soon as I turn that u back into x's. So my final answer, arctangent of 1 over x times x plus 1/2 times the natural log of the absolute value of x squared plus 1 plus c. All right, are there any questions about that one? Mike?
So would it matter if you had your u's x? X and u was u because would that matter?
Oh, wait, for which part? Up here?
Yes.
So if we allowed the u to be, what would you like u to be?
X. Would that
You
switch?
mean 1 over x?
So this guy right here? Or just the x from the denominator here?
Oh, okay. I see it now.
So yeah, in order to choose a u, I've got to be able to choose something out of here that is, when I pull it out, the rest of what's left over is times whatever that u is. So unlike a u substitution, I'm not allowed to choose something that's nested within parentheses. Other questions? All right. Okay, so let's open up the floor. Things you should expect on this exam. You should expect to be evaluated